Eniche. Well, that's the way we say hello in Mali. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics, but today we'll be studying the limit of algebraic functions. In this lecture, you will be looking up what algebraic functions are, what are the three different types of algebraic functions, what is the limit of a function, when is it that the limit of a function exists, and what is the limit of an algebraic function. We will also be looking up a sum which is very important for your examinations, and here first I'll leave you people to try out the sum, and after that I will be discussing the sum before you. I will also be giving you a second explanation of the solution, as then no doubt should be left. Then I expect you people to do the sum once in your copies without looking at the solution, so that all of this is very well assimilated. All this and much more is to be had in this lecture, so make sure that you're here till the end of this lecture so that you can have all of this, and when any sum comes your way which is of this type, you're able to do it with ease. Now children, before we get started, I like to entertain you people, and I like to take you people to this place where today I'm planning to have our class. This is Goina Waterfall, Kais region, Mali. This is an all-weather waterfall which is known as the Niagara waterfall of Mali. Here the water falls from a height of 164 feet, causing a thunderous roar which can be heard from miles away. The water drops into Senegal River and further into Talari Gorges, where you can raft as the water is turbulent and have a lot of fun. Now children, when you actually go to this place, make sure to have many young, which is a famous sweet delicacy made from honey and sesame seeds. Do tell all the people of Mali that you get to meet Eniche. And in this note children, I'll be starting off this lecture where again I'll be saying Eniche, but at this time it is going to be to limit of algebraic functions. So first children, let us discuss what algebraic functions are. Now if you talk about a function which has some a, b, c, d, the constants, and x, y, z, etc., the latter alphabets, which are the variables which are attached together with either some separator like a plus sign or a minus sign, or probably none. If it is none, then it will be a single term or a monomial. So if we talk about a function which say is something like ax cube plus bxy plus cz, you can say that you have an algebraic function, right? Now I told you people that there are also different type of such functions. So now next we come to that. If say you talk about the first type, that is known as a polynomial function, right? Or rather you can say a polynomial algebraic function. Next after this comes the rational algebraic functions, as these functions will have an algebraic expression in the numerator and one in the denominator, right? And after this children are the third, which are exponential or power functions, right, which obviously are going to be of the algebraic type. So I will quickly discuss one of each type. Let's say now we talk about the polynomial function. We've already had an example. So let's say now if we talk about some 4x square plus 13x plus 17, you know that this is a polynomial algebraic function. Now if we talk about a rational function, it can be say some x cube plus 7x square plus 13 divided by x minus 2 times of x square plus 13, right? Then if we talk about an exponential function, it can be, say, something like 2x plus 3, which is, say, raised to the power 17 sine x, right? So here, as we have algebraic expressions in the power or in the exponent or in the index, we call such functions as exponential, or they are also known as power, right? Or you can say power, whatever, right? Algebraic expressions, right? After you learn this, next comes, what is the limit of a function? Do you know what your limit is? If suppose you have been sent to go and play, right? I'm sure all of you people really like to play. Do tell me in comments which is the game you like, and obviously do say Eniche, right, everybody, so that I can understand that you watched the lecture and you've learned this. Once when you write anything, no, so what happens is it automatically sits in your memory. Then after some time when you revise it again, then you'll be able to learn this. This is the reason why I'm taking you to each and every corner of the world, making you people say how you just say hello, and obviously the rest of it you can learn. And then we have lovely places which I want you people to visit. So children, coming back to limit of a function, first I told you what is your limit when you're sent to play, right? I'm sure you'll probably go to play football, or you'll go to play cricket. Somebody can go and be in the gym, right? Like I regularly hit the gym, right? So there is a limit. Your parents expect that you will be back after some time, probably an hour or two, but that shouldn't be very late. You're not expected to go at, say, 5 and come back at 12 in the night, right? So this is your limit. That time for which you've been allowed to go outside and come back, that is actually the limit of you to be allowed to go and play. Similarly, children, when we talk about algebraic functions, or for that matter any function, they have their limits, right? So let's say now we talk about the limit of a function, a very important topic, and we can say that now here we are in the thick of calculus. It starts off from sets, then we go to relations, functions, and now we come to limit and continuity, after which we have differentiability, then differentiation, then integration, and then other many things, right? So next now we are going to talk about limit of a function, right? Okay, don't note down at this time, Shweta. This is the time when you just require to focus where I am. Make sure to sit straight with your spine straight at all times, sitting at a secluded place where there is no disturbance, so that you can focus completely, and make sure that you are focusing exactly where my pointer is. Now if my pointer is here at T, you should be here at T, and do not pick up any writing material, as that will disturb your concentration. Okay, so when we talk about the limit of a function, children, I'll quickly like to explain to you people what happens when we talk about a function which, say, is something like f of x is equal to, say, some x cube plus 7x plus 13, right, which is divided by, say, some x plus 3, right? So if we have x plus 3 in the denominator, can anybody tell me what is going to be the domain of the function? Yes, Shweta. Very correct. If we have the value of x to be minus 3, that is something which is not going to be possible for this function, because the denominator will become 0, right? So here we have a rational algebraic function, and this function is not defined if we have the value of x to be minus 3, because the denominator will become equal to 0, and then the function's value will become undefined. So as such, here if we talk about the domain of the function, then the domain of the function can be said to be an element of real numbers from which is subtracted this number which is minus 3, and the rest of the domain will not have any problem. We will get any of the other values when we keep, then correspondingly we'll get some value that will become the value of range for that corresponding value of domain. Okay, now children, we come to the concept of limit. So if here we now talk about those values which are not minus 3 but which are very close by. So let's say now we talk about a point which is here, say is minus 3, and now here we talk about a point which is very close to minus 3, let's say somewhere here, right, but not minus 3. Where, Shweta? Not you. Where? On the left side of minus 3, right? As you see here that we are talking about the values which are where? Which are on the left hand side of minus 3. So what are we talking about? We are talking about those values which are on the left hand side of this point which is minus 3, right? Remember, this direction is very important, whether you are on the left hand side or whether you are on the right hand side of a value. Now next we talk about another point which now say is going to be on the right hand side, right? So if we talk about now a point which is very close to minus 3, but let's say now we say that it is on the right hand side of minus 3. So which side? Where? Right hand side. Very correct. Now here we'll be marking this, that is we are talking about this point. Where is it? This point is actually on the right hand side, right? So if we talk about such sort of points which are very close to minus 3 and on the left side of it, right, then these points can be written something like this, that is minus 3 minus. That means it's a point which is very close to minus 3, but as there is a minus sign, that means it must be on the negative side of the x-axis, that means little on the left. Now if we talk about a point which is very close to minus 3 but on the right side of it, so obviously it is on the right side of the real number line, or in other words we can say that this is actually minus 3 plus, or in other words infinitesimally small amount of distance greater on the right hand side on the real number line from minus 3, right? Now normally what is done is when you talk about this infinitesimally small quantity, you name it to be h, right? That is, you say that this h is an infinitesimally small quantity and that is represented this way, that is h is tending to 0, right? So approximately it can be, say, some 1 upon 10 raised to the power 4, right? That is, in a way you can say that it is equal to some 10 raised to the power minus 4, or in a way you can say that this is actually 0.0001, right? So it's very, very small. As the need be, it can further be decreased, right? Okay, because every now and then we are dealing with some of the other measurements. That is how all of this mathematics come into being. Okay, now children, next, if say we talk about this point which is on the left hand side, this can also be said to be in terms of h. So how are we going to write it then? Now we'll be talking about this point which is on the left of it, said to be that it is some minus 3 plus h, right? Where once you can take the value of h to be tending to 0, right? So here now what we have is we have a point, right, which is very close to minus 3 on the left side of it, right? And when we say that our h is tending to 0, right, minus, then obviously that number is going to be subtracted, right, from minus 3. So this is a minute thing, that is h is tending to 0 minus, for this case, right? So when this value, which is 0 minus, or say something like minus 0.0001, then obviously this value is going to move on the left hand side of minus 3, right? And if we talk about a value for minus 3 plus h in terms of h, we can write it to be minus 3 plus h, where here for this case h is tending to 0 plus. Did you understand? So if you add this number, that is plus 0.0001 to minus 3, you will land at a point which is on the right hand side of minus 3, right? So all of this that I said to you people, I'm quickly going to repeat, because after this then I will be switching gears and come to something which is more complex. Now here children, we are talking about limit of any function. It can be an algebraic function, it can be a trigonometric function, it can be an exponential function, it can be a logarithmic function, or say any other type of function. When it is such a type of a function, then there are certain limits of that function. That means it has to stay within certain limits for its existence. For an example, I told you here that if we have a function f of x to be x cubed plus 7x plus 13 divided by x plus 3, this value of x cannot be equal to minus 3, because if it becomes equal to minus 3, in the denominator you will have minus 3 plus 3, which is 0, and if the denominator becomes 0, then the function becomes undefined, right? Okay, so this is the limit of the function. Okay, now if we talk about this point on the real number line x to be minus 3, it cannot be minus 3, but it can be a point which is very close to minus 3. And to approach minus 3, we can do it two ways. One, approach it from the right hand side, and the other is approach it from the left hand side. So when we approach it from the left hand side, we talk about the limit of the function from the left hand side to be the left hand limit, right? What do we say? We call it to be the left hand limit. Right? So whenever there is a function which is non-existent at a specific point, we can approach that point either from the left hand side or from the right hand side by a point which is very close to that point but not actually that point, right? So here you call it to be left hand limit, or we can even say that that is some LHL, right? In abbreviation, both of these are synonymous. Now children, if that point is being approached from the right hand side, we will call it to be the right hand limit. Right? And like I told you, the abbreviation can be written to be RHL, right? Okay, now if we talk about the left hand limit, or the limit of a function when we approach this point where the value of the function is not possible, then we write it in this way. We say that limit x tending to minus 3 minus f of x. That means here we are wanting to find out the limit of a function at a point on the left hand side of minus 3 but very close to minus 3, and that is why in the index you have this minus sign. This is just symbolic, as there is no number, so I'm sure you people must be feeling that this is nothing that you've read till now, but this is actually symbolic. This shows that a point is being talked about which is on the left hand side of minus 3 and very close to minus 3, right? Now if you talk about the right hand limit in a similar way, you will say that limit x tending to minus 3 plus. So this point is very close to minus 3 but on the right hand side of it, because there is a plus sign in the exponent, right, which is again symbolic, which shows that this point is one such which is a little greater than the value of x to be minus 3, right? Now, as we want to find out the limit of the function, so obviously we'll also be talking about the function, right? Now, in this case, the function is this that I've given you, that is x cubed plus 7x plus 13 divided by x plus 3. Now, children, if you talk about this, then there is an ambiguity. How much on the left? How much on the right? That's why we bring in an infinitesimally small number, right? Now, in one case, as you've seen, this infinitesimally small number is negative, excuse me, and in the other case, this infinitesimally small number is positive, right? When it is negative, then we'll talk about the left hand limit, right? So let's bring it on. Now further, I will write this step like this, that is limit h tending to 0 minus. Note, now there is no x. We have brought it all in terms of h, which is an infinitesimally small quantity, right? And as it is 0 minus, so its value must be negative. It must be something like minus 0.0001 or something like that, probably more or less, and so on, right? Now here now we'll talk about the function now also in terms of h, as now we can bring in this constant minus 3 plus h, right? So in place of x now we have the value of x, as the value of x here is actually what? If we talk about the value of this x, now it has changed to a different value. Now what is that value? I want to write that with a special ink, and that is what I'm searching. Yes, I've got it. So if you talk about the value of x here, it has changed now in terms of h as minus 3 plus h. You can't just add h to any number. You've got to add it so that the value of x reaches at that place. So thus you have the value of x to be minus 3 plus h. So thus now you know that this is a point which is very close to minus 3, and then we will talk about the value of h to be 0 minus. Then you will understand that it is on the left hand side of minus 3, right? Now if you talk about the other side, we have understood this, that x is actually minus 3 plus h, where later then we'll be stating that h will be tending to 0 plus, right? So now children, in the next step I will be writing this, how you write the limit on the right hand side, that is limit h tends to 0 plus, right, f of minus 3 plus h. So we now here know that as h is an infinitesimally small number but positive, has been added to minus 3, so obviously it will be on the right hand side of minus 3, right? When adding a negative number, it will further be moving on the left hand side, and when adding a positive number, it will be further moving on the right hand side, right? So this point that we are talking about, at which we have to detect the limit, right, is to be on the right hand side for the right hand limit, and for the left hand limit it has to be on the left hand side. Now if both of these entities are equal, then you will say that the limit of a function exists. So if this happens, then limit of f of x exists. Is that complete, Shweta? Yes? No. At where? Unless and until we talk about that point at which we want to find out the limit, this becomes incomplete. Or in other words, we can say that in mathematical symbolic language, we can say that just either LIM or LT, right? Both of these are perfectly fine. So limit of x tending to minus 3, f of x exists, right? So mathematically we can write it in this symbolic language, right? So all of this that I told you, I know it's pretty new for you people, so all of this I will quickly explain to you people. Now children, whenever we find out the limit of a function, what are we going to do if it is some other point except the point where it is not possible? Like if we want to find out the value of the function at 2, it will come out to be a valid value, right? But if we talk about a point which is -3, then it will come out to be invalid, as the value will not be got to, as the denominator is 0, so it will become undefined. So what am I trying to point to, Shweta? Can you tell me? No. I'm trying to tell you this, that whenever you got to find out the limit of a function, it is only when at that point the value of the function is not possible, not at any other point. Did you understand? So if we talk about a function where the function cannot become undefined, so you cannot talk about the limit of the function in such a case, right? For an example, if say we talk about a function which say now is something like f of x is equal to x cube plus 7 divided by x plus 3 whole square. Now can you tell me a point in this function where it is becoming undefined? Yes, Shweta? Yes, today the spotlight is on you, so I'll just be talking to you. Obviously the rest of the class is there, they can even raise their hands, but I'll just call them Shweta. Are you ready? Okay, so if you talk about f of x, we have it to be x cubed plus 7, and if we divide it by x plus 3 whole square, I'm asking you a point where this function is going to be undefined. No point. Perfectly fine, because if you keep any real value of x, you cannot make the denominator to be 0. For that matter, if here you talk about value of this function, then this function can become 0 at a point where the value of x is -3, and except that there is no other point where the function can become 0. So if we talk about the limit of this function, we will talk about that point which is how much? -3. Right? So -3 plus 3 will become equal to 0. That is why we will be talking about the limit of the function at -3. So there is one such point. Now if you talk about a point which say is for a function f of x, which say is something like this: f of x is equal to say some x cube plus 7x, right, plus 3 divided by x plus 1, right? And here you've been given the domain of the function, right, to be one such where x is say less than -3, right? So what will you talk about this function? What will be the limit of the function that we should try and target? I told you that if you talk about the limit of a function, you can only try it out at those points where the value of the function can become undefined, right? So if you talk about this function, in this function at -1, the value of the function will become undefined. But as the domain of the function is all those values of x which are less than -3, so we won't be able to reach this point which is -1. It is not there in the domain, so we don't have to talk about this point which is x is equal to -1. As such, the limit of such a function won't be found out. So is one thing clear? That if we talk about a function where limit of a function is required, it will only be that point where the function fails to exist. Then you'll be talking about some point on the left of it, some point on the right of it, and if at both of those points, that is the left hand limit and the right hand limit of the function is equal, then you will say that limit of the function at that point exists, right? So now I'll come back to this. So if say we talk about this function, we know that this function is going to become undefined at x is equal to -3, right? Because -3 plus 3 will become equal to 0, and thus the denominator will become 0, and thus the value of the function will not be possible, or in other words, undefined. But if we talk about the points which are very close to -3 on the left side of it, it's possible. It's not going to give you 0 in the denominator, right? Thus the function won't be undefined. It will come to a very small number, right? But obviously it's not going to become undefined, as the denominator won't be 0. Now if you talk about points which are on the right side of -3 and very close to -3, right, even those points, right, will not give you the denominator to be 0. They will be very close to 0, but they won't give the denominator to be 0. As such points are possible. The point which is on the right hand side, right, that gives you the right hand limit. The point which is on the left hand side gives you the left hand limit, provided these points are very, very close. When we talk about these points to be very, very close, we bring in this new variable where h is tending to 0, or in other words, h is infinitesimally small, right? Now children, talking about those points becomes easier to explain, as a point which is -3 minus on the left hand side of -3 can be written as -3 plus h, where h is actually tending to 0 minus. Now a point which is very close to -3 and on the right side of it, right, will be -3 plus h, where h is tending to 0 plus. Yes, Shweta? You are telling that on both sides we have -3 plus h, and thus it should not be equal. On the left hand side it should be -3 minus h. No, listen Shweta, I'll tell you. If you talk about this h, you find that this h on the left hand side is negative. And when you add this negative number to -3, obviously it will become further less. For an example, if say now we talk about a number which say is -14, if to it you add -7, won't it become -21, right? And is this not different from adding this to -7, right? So here what have we done is we have talked about subtracting -7 from -14, or we can even say that we've added to -14 -7. Obviously it will come back to the same, that is it will become -14 -7, or in other words -21. Now in the second case here, if say we talk about -14, and if we add to this a positive number that is 7, now will it be the same? No. Now this is going to become -7, because now we have added a positive number, right? And earlier you were adding a negative number. So when you add a negative number, then obviously what will happen is the number which results will be further less. And when you add a positive number, the number that results will now be on the positive side in comparison to the earlier number, right? As such here we can say that if we now talk about here, this case we are talking about the point to be -3. Oh, sorry. We are talking about this point to be -3 plus h when h is tending to 0 minus. As this is negative, this will further move on the left hand side and become more negative. Thus this will show you a point which is actually -3 minus. And when h is tending to 0 plus and you add to -3 this positive number, it will now be moving on the right hand side, and that will show you a point on the right side of -3 which is greater than -3, right? Okay, now if you talk about the left hand limit, it is also written by LHL. The right hand limit is abbreviated to RHL. Now when both of these are equal, then you say that the limit of a function exists, right? And this is written like limit x tends to minus 3 minus f of x, right? And then further we write this in terms of h, the infinitesimally small number. That is, now we write x to be minus 3 plus h, where we know that we'll be talking about h to be tending to 0 minus. So here thus limit h tending to 0 minus f of minus 3 plus h is the limit of the function on the left hand side of this improbable place, which was minus 3, right? Now when we talk about the right hand limit, it has to be on the right hand side of minus 3. As such, it will be limit x tending to minus 3 plus f of x, right? Now this minus 3 plus can be written in terms of h, as x can now be written as minus 3 plus h, although both of these resemble the same, but because h is changing once for the left hand limit 0 minus, and in the second case for the right hand limit 0 plus, so as such f of minus 3 plus h will now give the value of the function at a point which is on the right side, or at a value which is slightly greater than minus 3, right? Now children, here we will say that if both of these are equal, then limit of a function exists at minus 3, and mathematically you can write it like limit x tending to minus 3 f of x exists, right? You can also write it in terms of h, right? That is limit h tends to 0 f of minus 3 plus h exists, because when we talk about this h tends to 0, both side of it is understood. That is, once it must have been 0 minus, and in the other case it must have been 0 plus. So you can even write it in terms of h, that is limit h tends to 0. Now here we will not put up a plus sign or a minus sign. It will be understood that once it will be negative for the left hand limit, and once it will be positive for the right hand limit. So f of minus 3 plus h exists, right? Both of these are correct forms of writing this. So Shweta, is it perfectly clear? Any confusion, any doubt? Okay, now children, after we've talked about the limit of any function, the existence of limits, now we talk about the limit of an algebraic function. So when we talk about the limit of an algebraic function, if the function is a polynomial function, there is never any problem, right? Because everything is in the numerator. As such, whatever values you keep from the real number set, you will never have a problem in calculating such a function. So you will never have to talk about the limit of such sort of functions, right? Now if you talk about rational functions like the one that we've just discussed, that it has an algebraic function in the denominator, you've got to just see that which is that point at which the denominator is becoming 0. Because if there is a point at which the denominator is becoming 0, that means that is the point at which you got to talk about the limit, right? Now if we talk about an exponential function, right, or a power algebraic function, then we've got to see to it that the power is such that, can you tell me, Shweta? Anybody else from the class? No? Okay, this is always possible, but there is one anomaly. Can anybody tell me? Okay, I'll tell you. If say now we talk about a number which say is something like this, minus 13, which is raised to the power say some 17, right? And now if you make the denominator of this to be say some 3, right? Now don't you think that this is going to become a complex number? And complex numbers are not accepted when we talk about real number mathematics, right? As such, this is not coming out to be a real number, because here further, like I'll tell you further, this is going to become equal to minus 1, which will be multiplied with 13, and the power is 17 upon 3, which can further be written as minus 1 raised to the power 17 upon 3 and multiplied by 13 raised to the power 17 upon 3. Now there is no problem with the number on the right hand side, that is 13 raised to the power 17 upon 3. It is just an irrational number, that is, it is a third root, right, of 13 raised to the power 17, right? But if you talk about the number which is on the left hand side, it is not even I, but obviously it is an imaginary number, right? So we can't talk about numbers which are in any root form but negative, right? So if there is any negative number, you cannot find out its square root, cube root, nth root, and here we are trying to find out which root. We are trying to find out its cube root. So obviously this will also give you a complex number, and we are here just talking about real numbers. So one thing which becomes a condition is if you talk about this number which is in the exponential form, a power algebraic function, then the base cannot be negative, right, if the power is fractional. You got to remember this, right? So here the condition has to be that if you talk about this base, right, this base which is normally said to be a, right, is to be greater than 0 for a fractional index, right? This is something which has to be taken into care. So if you're sure that the index is fractional, then you got to ensure that the base has to be positive. But if this is not there, then there is no problem, right? If you just look at this number, that is minus 13 raised to the power 17 upon 3. If we just talk about minus 13 raised to the power 17, there is no problem, right? So even if the base is negative, but if you talk about the power, if that is from the set of integers, then we will say that this is perfectly possible, right? But if it's a rational number, then this is going to become a complex number, and as such that will become unacceptable, right? Okay, now after this, now children, as we've discussed the limit of a function, that means we've been able to understand if it is a function of all of these three types. When is it that you will have to find out the limit of a function? For a polynomial function, it's never. For a rational function, you got to ensure that the denominator never becomes 0. And for an exponential or a power function, you got to ensure that the base is positive if the power is fractional, right? I've written this here, that the base, that is normally a, is to be greater than 0, right? Obviously from the set of real numbers, that's not a problem, right? And it is only when you're talking about a fractional index or a fractional power, right? Okay, at the moment we'll just be discussing about rational functions. So I'm sure all of this is perfectly clear with you people. Now children, we come to the next part, which is talking about the limit of this algebraic function.